Okay, so I'm Alexander Brearley. I'm a physical oceanographer at the British Antarctic Survey. And
David Marshall, physical oceanographer at the University of Oxford.
And we're the work package leads for work package 2 of SO-CHIC. So SO-CHIC as a program is primarily tasked with understanding the central role of the Southern Ocean in taking up heat and carbon dioxide from the atmosphere. The work package 2 is specifically involved in trying to understand how heat and carbon get from the surface layers of the ocean, what we call the mixed layer, into the ocean interior. And to do that, we're employing a suite of different tools. We're employing both a network of cutting-edge autonomous instruments to observe many of those key processes, and also a bunch of high-resolution models, which David can talk a bit more about.
Yes, so we're using some very high-resolution computational models to look at the effects of ocean eddies, in particular on the observing strategy, which Alex is involved with. So the ocean is full of eddies. These are like weather systems in the atmosphere, but whereas atmospheric weather systems occur on hundreds of thousand kilometers, ocean eddies are much smaller scale, especially at these high latitudes, where maybe it's a 10-kilometer scale. And then embedded within these mesoscale eddies, as we call them, are even smaller eddies known as sub-mesoscale eddies, maybe on the kilometer or 2-kilometer scale. So computationally this is extremely challenging, but it's also, for me, what makes the subject very exciting and interesting.
And it's just incredibly fun to have this synergy between this incredibly exciting data that we're getting back from the autonomous platforms alongside the modelling, and it really feeds into better understanding of, say, uptake of heat and carbon out of the atmosphere, and feeding into better predictions of climate in the 21st century and beyond.